Hello, welcome to EriQuestions.com YouTube channel. My name is Elif Bayram. Today I prepared a brand new PDD question for you. An architect is verifying the size of concrete footing 2A. What is the required surface area of this footing? Reference formula is surface area of footing equals total load on footing divided by soil capacity. As part of the question, we are also given a load-bearing values table for different types of ground materials like bedrock and sand and gravel. And we are also given different types of loads for the structure. So if you wish to solve the question on your own first, please pause the video here. Otherwise, I'm going to continue to solve the question. So in this question, we are given a plan diagram and we know that there are columns and footings. The question is asking us to find the surface area of the footing. In structural systems, structural members like columns and footings are designed to receive the loads, vertical loads, from top and deliver them to the bottom. So here we need to find the area supported by the footing so that we can calculate the loads that are applied on the column and the footing below. Typically, this load distribution or the tributary area per structural member looks like this, as these colorful rectangular areas that I highlighted on the diagram here shows us the tributary area for each structural member, each column and each footing. So here in the structural system, since the question is about the footing 2A, I focused on that footing and I calculated the area supported by that footing. So when you look at the axis 2, you see that axis 2 is 20 feet away from axis 1 and 20 feet away from axis 3. And when you look at the ABC axes, you see that axis A is 12 feet away from the axis B. So since the loads are distributed equally between structural members, we also take half of the distance on the each side to find the area that is supported by this footing. And in addition to that, we are given loads in the question. So this tells us that we need to find the surface area so that we can be able to calculate the loads that are applying on that tributary surface area. That is the job of the footing that is behind of that area. So each structural member shares this equally, and each structural member carries the portion that they are responsible for. So we know the loads per square feet. It's given in the question. We have snow loads and dead loads. And once we find the tributary area by calculating the surface area, we can find the total loads that are applying. And here the tributary area is 20 feet times 6 feet, which is 120 square feet. Now that we found the tributary area, let's look at the solution together. So we already found the area, that's 120 square feet, right? Now we are going to look at the total load per distributary area. We know that there is 30 psf snow load and 30 psf dead load. The total load per square foot is 60 psf. When you look at the total load on the footing, you need to multiply the per square foot value with the total surface area. Because if each square foot of this tributary area is in charge of carrying 60 pounds, the total of this whole thing, which is the 120 square feet, is in charge of carrying 7,200 pounds of loads. So the other portion of the formula is soil capacity. The question says the soil type is sand, and sand has 2 kips vertical foundation pressure. When you convert 2 kips into pounds, that's 2,000 pounds. When you insert the numbers in the formula, which is footing surface area equals the total load on footing divided by soil capacity, and you will find that the answer is 3.6 square feet. Here, instead of formula, I think what's more important is to understand how the whole system works. This system is composed of a slab, columns, and footings. In structural design, all of these structural members are in charge of transferring loads that are coming from top all the way through the bottom to the ground. The ground type matters, as you see in the question, because different materials have different load-bearing capacities. So when these loads are transferred, it is important to understand the intersection points, when the slab is touching the column, when column is touching the footing, and when footing is touching the ground. So when you look at these intersection points, what matters is the surface area. The load concentration on that surface area is very important, because when you spread a load on a larger surface, it's easier to carry that. When you are concentrating that on a smaller surface, then that smaller portion of the structural member is gonna do more job, obviously. So when you are trying to find the surface area at that intersection between two different structural members, what you typically do is you first calculate the total loads that are being transferred from top to bottom, and then you divide that by the capacity of the load-bearing member that is beneath the top member. So here, the member at the top is footing, and the load-bearing element is the ground. That's why we found the total load first, which is 7,200 pounds, and then we divided that by the soil's load-bearing capacity. So by doing this, we found that surface area of the footing that should be minimum 3.6 square feet, so it can be able to transfer those loads that are coming from top to the element below. Element below here is the ground, like I said. If you are having a hard time to understand structural systems, if you are looking for an easy way to learn the basics for the area exams, I would highly recommend you to check out my video lecture series. I have a couple hours of structural recordings there with a bunch of questions explaining all the basics that should be enough for you to pass your exam successfully. And in addition to structures, you are going to find lots of other content. It is almost like 20 hours of content with 242 extra questions. So I would love you to check that out. I wish you the best of luck with your studies and exams. Please don't forget to subscribe to my YouTube channel. Until I see you with a new question next week, have a great day. Bye-bye.